there's not even a place to stay or like a hike I can take.
No,
or
not
like
really.
can't set foot on it. It just sounds
Nope.
like there's some limitations.
Yeah.
Hi, I'm Ryan. I'm a science teacher.
I'm Cheryl, and I slept through science.
Each episode will tackle a science question you may have learned in school, but can't quite remember or fully explain.
And I'll take the risk of asking the dumb questions so that we can all understand the science we slept through.
The bell has rung. Let's get started.
Welcome to lesson 83. We are in our deadly solar system unit. Cheryl, what deadly part of the solar system are we talking about today?
Well, now that we've moved on, we did Mars, and then we did the asteroid belt.
Yep.
And we all know the planets that come next are the gas planets.
Okay.
So let's talk about the gas planets.
Okay. What do you want to talk about the gas planets?
We can get into specifics with future weeks, but I have a very foundational question that I need to understand about the gas planets. And then we'll talk about individuals in future lessons. I don't really understand how gas can be a planet.
Okay.
Because it's not a solid.
Okay.
So is it the same kind of gas as when I think of, as in there's liquid, solid, gas? Is it that kind of gas? Or is there do we mean something else when we say it? Or are there also solids in there, but there just happens to be a really murky atmosphere, so we call it a gas planet? But how did all this gas just get sucked in together? But can I stand on a gas planet? But I can't stand on gas, so I don't feel like I could stand on a gas planet. Can I breathe it?
Okay. So it sounds like your big question is, can I stand on a gas planet, or can I breathe it? Is it an actual gas that makes up a gas planet?
Yeah.
Well, let's dive into the pre-assessment. What do you think? Do you think it's gas, like we talk about gas here on Earth, solid liquid gas?
I think it is, because otherwise we'd use a different word. Because I think in science, scientists are specific with their words. They're not throwing around language to mean multiple things. It feels like there's a lot of specificity. So I'm gonna say it is. Yeah.
Okay. Then that leads to one of your next questions. How can it be a planet if it's not solid? Or is it solid somewhere? What do you think? Do you think that it has a part that's solid?
That's what I've been wondering. Is there a solid core and then there's just a lot of gas, and that's the atmosphere? Or is it literally just gas? And I don't understand how gas could have could do those things that we talk about planets needing to do, the fact that they developed enough mass that they became circular and that they have gravity. I don't think of gas as having that ability. Even when we've talked about gas, when we talked about Mercury, we talked about how it doesn't have much of an atmosphere, and so if there was any air there, it would just go off into space. Or if when we talked about the vacuum of space, and if you were in a spaceship, there'd be air inside your ship, but if the door got blown off, it would just go and go. So then it feels like if a gas planet is only gas, what's keeping it together? Why doesn't it just I don't know, dissipate or whatever? But the biggest planets are these ones. So
yeah, which is backwards from what you expect, is what I think you're saying.
Yeah, I don't expect gas to be able to do any of that. Also, last week, we were talking about the asteroid belt, and we were talking about how that was kind of the beginnings of our solar system, and then these different objects slowly came together. And I don't even think of gas as an object. And so did it start as solid and something happened and now it's all still hanging out? I don't think it is, though. So I feel like there's got to be something else. And so then my guess would be that there's some sort of like solid core and it just has a very, very different atmosphere, or is like than what we have, because I guess we have a gas atmosphere as well.
We do, yes.
So, but then what's the difference? There's going to be a difference then if we're calling those gas planets and we're not saying Earth is a gas planet.
Right. What do you think the difference could be?
That it's I mean, thickness is my first thought. Just that there's either in like thickness in the whatever the air is that's there. Although Venus, we talked about Venus having a lot of pressure, so you could argue, thickness doesn't feel like a very scientific word. You could argue that Venus has like a thicker air or atmosphere to it too. And so I don't know. It has to be something else then. I mean, it's visible, right? Like we can see these planets have a color to them and you can see them. And so like, it's not like if what we're seeing is gas, then it's a colorful gas. It's not a see-through one. So I don't know what's up with that. But like, can I walk on it then? But I can't walk on gas.
What do you think?
I don't think I can. I bet I could breathe it. Can I breathe a planet? I mean,
Depends what you mean by breathe. Okay. Like inhale.
Yes. I couldn't survive there probably, because I'm guessing that it's toxic to my body, whatever those gases are made of. But can I breathe a planet if it's made of gas?
And you think you could?
Very quickly. Yeah, I think I could. It's just funny to think about breathing a planet, though.
That is not standard way of thinking about it. Well, Cheryl, I know this has been quite puzzling for you, but hopefully I can separate things out and help it make a little bit more sense for you.
I hope so.
Well, let's start with gas planets are gas because, like you said, they're gas just like gas on Earth. Solid, liquid, gas, a different phase of matter. As a matter of fact, Jupiter and Saturn, the nearest gas planets, are made up mostly of hydrogen and helium, which is the same stuff that the sun is made out of, believe it or not.
Oh, wow. Yeah. Interesting. Okay.
Now, there are different substances beyond just hydrogen and helium, and that leads to a lot of the different colors and patterns and things that you see in the surfaces of the planets that you can kind of see from a distance, but it's mostly hydrogen and helium.
Wow.
And like you said, if you were to breathe it in, you could, because it's a gas. But if it's mostly hydrogen and helium, what are you missing that you would be required to breathe in order to survive?
Oxygen.
Exactly.
Yeah.
So yes, it would kill you if you tried to breathe the atmosphere of a gas giant. That would be challenging.
But in the process, I could get a funny high-pitched voice.
Yes.
Without oxygen.
Without oxygen, while you suffocate and die. But you'd have a fun voice.
It would sound pretty funny.
Sound pretty funny. Yes. So then your question is there an actual surface? Is there a solid core? Is there something in there? And the true answer is we don't know for sure.
What?
It's possible that there is. It's also possible that there isn't. One of the things that we know, especially of Jupiter and Saturn, is as you go in, as you kind of go from the surface of the clouds in, the pressure increases. You mentioned Venus earlier and how there's super high pressure on Venus, and that's true. These planets are so much bigger than Venus. For example, the size of the red spot on Jupiter, familiar with the Great Red Spot storm? It's about the size of the entire planet Earth, just for scale. Yeah.
Wow.
So much, much, much bigger than our planet. And so when we're talking about pressure, there's a lot more gas. And as that gas is pushing down, it actually changes the phase from gas to liquid. Because if you put things under high pressure, you can change phase. So temperature isn't the only thing that can do that, but pressure can also. But it doesn't happen like all of a sudden. It's a gradual change. So as you're going deeper and deeper, all of a sudden the gas is getting thicker and thicker until it's kind of not really gas anymore. It's more of a liquid.
That's so weird though, because when I think about my Instant Pot and how it pressure cooks, it's increasing the temperature.
No, it's increasing the pressure. I mean,
Well,
it
yes.
also does have a heating element.
Doesn't the pressure increase the temperature?
Oh, that's a whole nother episode. Yes, but also no. But continue to apply this to our planet.
Yeah, because it cooks my chicken faster.
Yes, it does.
And so that's related at least to temperature and it increasing or being more effective or something like that. There's like increased temperatures going on in my Instant Pot.
Yes, and there are as you go deeper into Saturn as well. You are also increasing the temperature. As a matter of fact, inside Saturn and inside Jupiter, you can have temperatures that are hotter than the surface of the sun. And they're a liquid because of the amount of pressure.
Is it, but the liquid's not water though. So is it a liquid that turns to gas at a higher temperature?
No, that's a good hypothesis. No, it's like liquid hydrogen and helium.
Why does it turn from gas to liquid as it gets hotter?
Because it's not just about temperature, it's about the pressure.
Weird.
Because so remember back to when we talked about hot and colds and we looked at all of those different molecules and I had all sorts of little models of things that were dancing around. Does that sound familiar?
Yeah.
And as they were moving faster, they were farther apart from each other, right? And that's why they changed from one phase to another. Well, the other way to lock them in place is to push them in place. So that they have a higher temperature, but they can't actually move away from each other because of how closely they are being pushed into each other. The pressure can also affect the phase. In our everyday life, we are not experiencing huge changes of pressure. It's more or less one atmosphere of pressure most of the time. Obviously, if you're like at the top of a mountain, it's lower. And if you're deep in a valley, like Death Valley or something, it's higher than that. But in general, it's about the same.
Yeah.
But when you are able to change the pressure significantly, one way or the other, you can change the phase.
That's wild.
Yep.
Okay, so in addition to, obviously, like I could only take 1 or maybe 2 breaths on these planets, I would suffocate. Well, I'd just suffocate in the time it takes a human to suffocate if I was there.
Right, with several minutes, yeah.
Oh, okay, cool. So I'd have a funny voice for a little bit. But then also, it sounds like I really can't stand on this planet.
There's no place to stand, no.
So if I were just like dropped by a spaceship onto, like stepped out of a spaceship onto this planet.
Quote, unquote.
Yes. Yeah. Sounds like there's a lot of things that would kill me. But one of them is I would just sink through the gas until I got to the liquid, which I'm guessing would also like maybe burn me alive. But like, or I would become a liquid maybe.
So a number of things would happen probably before you even got to the liquid. You would be crushed by the pressure.
Wow.
And potentially, and this I don't know, I would have to do some looking to figure out. Also, the temperature goes up as you're going in as well. So you also could get like cooked. But which one would actually happen first? I guess I don't know. You get crushed or cooked first.
I get crushed. And then after dying, I might just become a liquid at some point. Or do you
Yeah,
think I
I don't
just
know that
hang
you
out
would
as a solid?
become a liquid because you're not a pure substance. Hydrogen
Oh,
and
that's
helium
true.
are more, so it's easier to change the phase of that as opposed to the phase of
Okay.
you, because you've got bones and muscle and skin and all of those
Okay.
things. But I'm not going to say that you wouldn't liquefy. You might.
A lot of crazy things would happen to my body.
A lot of crazy things. So are you looking forward to a trip out to a gas giant soon?
I think I'm going to stick with the solid planets for my planetary travels.
Yeah, that's
It just
probably a good idea.
if there's not even a place to stay or like a hike I can take,
No,
or
not
like
really.
can't set foot on it, it just sounds
Nope.
like there's some limitations
Yeah.
there. But it is very funny to me that I could breathe a planet.
I mean, you could argue that you breathe Earth every day, right?
Yeah, I guess if
Because
you,
the
yeah, 'cause
atmosphere,
the atmosphere is part
of
of Earth.
Earth is as much a part of Earth as the atmosphere of Jupiter or Saturn or Uranus or Neptune. Those are all parts of those planets.
Yeah,
And that would be the part you'd be
okay.
breathing, would be the atmosphere.
Okay. It's just a lot of atmosphere then.
There's a lot of atmosphere. And then when it transitions, it doesn't transition into a solid. It's possible that with enough pressure, there may be a solid core on the inside of the gas
Interesting.
giants, but we don't know that 100% for sure.
Would they have to send something in, but they'd have to send something that, just like with Venus, could withstand the pressure?
We don't have something, because again, those planets are so much bigger than Venus. There's no way for it to withstand that. So instead, we've sent probes that measure other things that give us an idea about what's inside, because visible light can't go through the clouds, but other forms of light and electromagnetic readings and things like that, there's other things that we can measure that give us hints and clues to what's inside.
That's cool.
I think so. Now you're an expert on all things gas planet, right, Cheryl?
Yes, absolutely. I know all of the gases and the planets.
Perfect. Great. Then you're going to ace this quiz.
Amazing.
Amazing. First question. Are the gas giants made of the same type of gas as we see on Earth?
Yes, they are.
Yes, they are. Yes. Second question. What elements are the gas planets mostly made of?
Helium and, did you say carbon? No,
I did not.
That's just what life is made of. Never mind.
Mm-hmm.
Gosh, it wasn't carbon dioxide, I don't feel like. No, hydrogen?
Yep.
Yeah, okay.
Yep.
Cool.
Hydrogen and helium.
Okay.
Yep. What happens as you go deeper into a gas giant?
The pressure increases a lot. And the bigger it is, the more it has an opportunity to increase, it sounds like.
Okay. And then what does that do to the hydrogen and helium?
It changes phases from a gas to a liquid because the molecules get all squished together and have no choice.
Yep. And what happens to the temperature?
It increases a lot. It gets very hot.
Crazy.
Yeah.
What causes the interior? I think you kind of already answered this a little bit, but what causes the interior of a gas planet to become a liquid?
Pressure.
The pressure. Yep. The intense pressure of all of the outer layers of the gas of that planet. Yep. Final question. Do gas planets have a solid surface?
We don't know, Ryan. And if scientists don't know, then I don't think I know.
We don't know. It's possible that they do. It's also possible that they don't. It's also possible that some of them do and some of them don't.
That's a good point. It's not necessarily all or none.
No, it's not necessarily all or none. Well, Cheryl, do you feel like now you're well prepared to dive into some specifics about some specific gas planets in future lessons?
Yeah, this gives me way more of a foundation so we can talk about those 4 remaining planets.
There you go. You weren't quite sure,
Yep.
but you got it. Yep. 4 remaining planets. All right. But we're going to have to save that for another lesson. So why don't you pack up your stuff and get ready for my closing remarks?
You can follow us on Instagram and Facebook at I Slept Through Science or on Twitter at Slept Science.
If you have dumb science questions like I do, please send them to us. You can email us at isleptthroughscience@gmail.com, or you can even send us a voice memo and we'll play it on the podcast.
Please rate and review our podcast to tell other people what you think about it, subscribe to make sure you don't miss an episode, and share about our podcast on social media.
Thank you to Beth Reed Miller for the artwork. You can check out more of Beth's artwork at Beth Is Something. Okay, great. Thanks. Bye.
The bell doesn't dismiss you. I dismiss you.